Friends, colleagues, and listeners, welcome again early in 2025. And we've got a great guest on today and a subject matter that I've got a personal interest in. The person I'm talking about is John W. Piasecki, who's the president and CEO of Piasecki Aircraft Corp. John, absolutely lovely to have you on board, sir.
Thank you, Chris. Well, I'm happy to be here.
Yeah, it's a real pleasure. Now, John, what I normally do is I go over a bit about the person and the company, but I think you've got such a vast bio and such an academic background. What I'd like, if you wouldn't mind, is can you just give us a little brief as to how you got into what you're doing and what you at Piasecki Aircraft Corp actually do?
Well, Chris, the my um, participation in the vertical flight industry was sort of I was born into it in the sense that my father was one of the original inventors of the helicopter, and he and a bunch of his compatriots developed and flew the second successful helicopter in the United States, and then
Right.
probably most known for the invention of the tandem helicopter, which then led to the creation of the Piasecki Helicopter Corporation, which really in the 50s was the largest or one of the largest helicopter companies out there and really pioneered the application of the helicopter and is represented today in the Chinook helicopter, for example, that is operated by the U.S. Army and the British Army and many other services around the world. In 1960, my father sold that company and founded a new company with his R&D group, and that's the Piasecki Aircraft Corporation. And my brother Fred and I really sort of grew up in that company. I mean, we went to work every Saturday, growing up, and you know, started off emptying the trash cans and cleaning the toilets, and then ultimately um, took on more and more responsibility. Interestingly enough, I had no intention of working for my dad when I
Yeah.
was in college. I was going to go off into another field, but unfortunately, he had a bad car accident. So
Okay.
I came and helped him. And he said, "John, just for a couple of years when we get the thing straightened out." And that was what, almost 40 years ago. So
Brilliant. Brilliant.
um, I love the industry because vertical flight is a very unique capability, and it's demanded by missions both in the military and commercial arena that have a high degree of urgency associated with them, whether it's rescue and medical
Yeah.
evacuation or insertion of special operators or resupplying troops or doing humanitarian recovery. It is a unique capability that attracts unique people with urgent needs. So I love it,
Yeah,
and
man.
I'm happy and blessed to be working with my brother Fred to take these problems and turn them into innovative ideas and demonstrate them and be a catalyst within the industry.
Absolutely brilliant. And I think one of the things, like with my background, one of the things I love how you started there about saying you started with the trash cans and the toilet cleaning. There's no better way than to start at the basics and then see what everything's about. You get a lot of respect for that as well. So I'm sure your dad had the right message in place when he suggested that you and Fred do that. Hello, John.
Yeah, I'm here.
Sorry, mate. Sorry, a little bit of a lapse there. It's not often that people wait for me to speak more, so I appreciate that. But yeah, what I was saying is, I think that's absolutely brilliant how your dad got you both started. Now, one of the things I wanted to ask you because you've won awards and you won the Vertical Flight Society's Paulie Houter Award,
Yeah.
and you're also vice chair of various organisations and associations. Obviously the credibility is there. What has been the biggest reward and also the biggest challenge that you've faced when looking at the development now of the VTOLs?
Well, Well, first of all, let me say that, all of the accolades, awards that I or the company have had is really doing what we do is very hard. And I tell all the young engineers that the problems that we take on are not easy problems.
Yeah,
And perseverance is probably the most important ingredient to success because you're going to get knocked down, you're going to fail. You got
yeah,
to have the courage to get back up, and the humility to understand what you may have not gotten right, and the passion to keep the program going, and ultimately find the truth. And sometimes the truth is not something you want to hear. Something may not be a practical solution. That's okay. We learned, and if you keep a philosophy of pursuing the truth with passion and perseverance, you're going to win in the end.
yeah, yeah,
Um,
yeah. Wear
uh,
everything down. Yeah,
yeah. So the company's really focused on identifying key challenges in the vertical flight and aviation sector and developing innovative solutions, improving those. Um, I look at the marketplace in terms of military requirements and commercial requirements. There is crossover between the two, so there is a sort of a subcategory or an intersection in the Venn diagram where there's technologies applicable to both.
yeah,
But the military has very demanding performance requirements that have evolved over the past some years, where the threat environment has gotten so high, and that for instance in the Ukraine, the lethality of weapons and drones, and in the Indo-Pacific, where the problem is compounded by vast distances.
yeah.
You're defending island chains without runways on them. Vertical flight performance requirements have gone well beyond just the conventional helicopter capability. And so there is a need to be able to expand the speed, range, endurance of vertical flight platforms that are often operating from ship decks and supporting small distributed units, that are defending islands, um, and in more land mass oriented battles or wars like the Ukrainian situation. The large formation of ground units are very vulnerable to massed artillery fires that are being
Yeah.
informed by drones. So survivability really depends on disaggregating forces and operating in small units, and each of those small units having the mobility to constantly change location and disposition relative to the enemy. That's the only way they can survive. So, in order to
It's,
keep those units supplied with food and ammunition and all the essentials, their vertical flight is a critical element. But you can't dump a whole day's worth of supply on them because then they're no longer mobile.
yep, yep,
So,
yep.
so automated some resupply is another area that I think is going to be critical, especially when you consider that in many cases the normal ground lines of logistics transport are not going to be available, or they certainly can't be counted on as these small units
Yeah, exactly.
move.
Can I ask you? Can I ask you? It might be a stupid question, but it's one that I'm really interested in because I love what you're saying, and I could just imagine you guys, you and your brother and the rest of the team, coming up with solutions for all these challenges. But just one thing I want to ask: how easy is it to track the movement of these VTOLs? Because obviously, in the sensitivity of where people are, and like you said, repeat supplies, etc. How easy is it to track their movement, and also how easy a target would they be?
So there's I can't there a lot of this gets into classified information,
Sure, sure.
but just generally speaking, um, the enemy's capabilities to identify and track aviation targets has vastly improved.
Yeah,
And um, you almost have to operate on the assumption that you are seen. And really, I think where the military is going is to overwhelm the adversaries with a multiplicity of problems such that, yeah, okay, they know all these things are flying around, but um, many of them may be decoys, or they
yeah,
are, or they're operating in such a way as they hide what their true intentions are. Um, I'll give you an example that in the Ukraine, the artillery, it's really an old-fashioned artillery battle informed by precision location using drones, and uh, you can maybe get off a small number of rounds, but then you've got to move, or you're going to be subject to counterfire.
right. Yeah, yeah, yeah,
And so you have these mobile artillery units, and they need to be resupplied with artillery shells. And but if you don't want to fly the shells directly to the unit,
yeah.
so because you'll be disclosing their location. So
Exactly,
perhaps it's
exactly.
a intermediate point where they pick up their resupply along the way, or you offset the supply to an autonomous ground vehicle that then transports it the final mile or what have you. So the I guess the quick answer is um, yeah, the enemy, you have to assume the enemy can see you, and you have to
Yeah.
operate accordingly.
Yeah, that makes it very, very clear. Now, just a few questions, if I may. So the first one would be, right, how do you see hydrogen electric VTOLs, like the P90 impacting commercial aviation, particularly in executive transport and urban mobility?
Well, the P890 is is a slow rotor compound helicopter that has an electric propulsion powered by a high temperature PEM fuel cell, which is a new tech. Fuel cells have been around for a long time,
Yeah,
but there's a number of cars that are out there. Most of that technology is low temperature PEM fuel cells, which are great for these ground applications and some aviation fixed wing applications that are more accepting of higher mass solutions. But in vertical flight, every pound is critical. So
yeah,
key performance parameters like specific power will really drive the need for lighter weight solutions. And so, um, a lot of the electric VTOL industry got going on the promise of lithium ion batteries being the power and energy source. And I don't know who said it. I think maybe it was Edison. He's saying that you have liars, bigger liars, and battery suppliers. And
yeah. Right.
I don't want to castigate the battery industry at all. They're working hard, but um, in order to be able to do the missions that our customers are interested in, which frankly are longer range missions that are currently being done by turbine powered helicopters, the
Yeah,
energy density that is actually being realized is not adequate. And furthermore, when you take these batteries and you put them through the power cycle of a vertical lift mission, which has huge discharge, very high discharge rates, what we call C rate, at the beginning of the mission when you take off, and then at the end of the mission when you're landing, that's those power cycles then translate into a significant reduction in cycle life of the battery. So if you have a battery that, in a ground application might have, 4,000 cycles,
Yeah.
in a vertical lift environment, it maybe has 400.
Right.
And the problem with that is when you take that reduced life and you put it through the calculator and you calculate flight hour cost,
Yeah.
it comes out to only a marginal difference from the turbine. And I can tell you right now that the commercial operators are very conservative operators. I mean, they have very thin margins, and they're not going
Yeah.
to take the risk of adopting a new technology unless there's a hunky savings. So
Yeah.
we focused on hydrogen fuel cells because we think we can get about 5 times the energy density of batteries. Maybe with high temperature, I think we can do about 2 to 2.5 times the increase in specific power relative to traditional low temperature fuel cells. And if we're successful in implementing that within the volumetric constraints of helicopters, um, we can provide almost as good performance as a turbine, but at 50% of the operating cost and with zero emissions and low noise.
Wow.
So
That's amazing, huh?
yeah, that is our objective. Now, as a research organization, we're all from, as we say in America, we're from Missouri, and which is known as the Show Me State, and we've got a great relationship with the fuel cell stack developers, and Zero Avia is a leading company in the high temperature PEM fuel cell technology world, and we're working very closely with them to implement the early iterations of this technology onto a small helicopter, a wonderful little German coaxial helicopter that will fly later this year. And that will be the world's first high temperature PEM fuel cell manned flight. And then informs the development of a 660 kilowatt full scale propulsion system that will be the heart of the PA-890 and hopefully find home in on other rotorcraft and aircraft. And we will ground test that propulsion system in what we call an Iron Bird in our industry, and that will validate the performance and inform not only us but the FAA and the Air Force
Yeah.
on the key certification requirements that we'll need to implement in order to deploy the technology in an operational environment.
Brilliant. So once it goes past the Iron Bird test, um, then in principle, then it can go into further trials. Yeah.
Yeah, we will have, at that point, we will have objective evidence to substantiate the commercialization of the technology. I know that a lot of money's been spent in the or invested in the eVTOL world. At Piasecki, we like to make sure that the technologies that we're pursuing earn their way onto the aircraft through objective demonstration at the subsystem and system level before we commit to our customers that we're going to be able to deliver a certain capability that they're going to have to pay money for.
Yeah, exactly. And all being well, what would the first simulation or the first trial flight look like?
Um, the first flight right now is planned to be on a technology demonstrator prototype of the PA-890. And when I say that, one of the features of our development philosophy is to use as much off-the-shelf components
Yeah.
as possible. So it might be a little bit of a Frankenstein, but um, that has huge benefits in reducing the time and cost to prove the technology at scale.
Yeah.
So that would be a 3 to 4 year technology development. I would look to invest as much as possible in the dynamic system that is the long lead element to actually developing and deploying a certified aircraft as part of that demonstration.
Fantastic, fantastic. And then obviously another question then, what commercial opportunities do automated area logistics offer? And how soon do you think we could expect widespread adoption, especially
Yeah,
for the cargo or delivery services?
well, just to stay on the hydrogen fuel cell for a second, the P890 is really focused on the emergency medical
Yep.
market. We've got about five launch customers that are, patiently working with us and developing requirements, what have you. Um, uh, the uh, the P890 certainly could operate in the logistics arena, and one of our customers is very focused on actually medical logistics.
Yep.
Um, but there is a broader need for uh, very affordable but capable autonomous logistics platforms, both in the commercial and the military markets. That is probably smaller. The P890 is about a to 8,000 pound gross weight machine,
Yeah.
and in the military side of things, you want something that is able to resupply these small units, but if it is identified and it is destroyed by the enemy, you don't have to go before Congress. Um, you can afford to lose it. It's risk worthy is one of the terms that the customers use. Um, so we are focused on developing a family of cargo UAS that range from 500 pounds all the way up to 2,000 pounds. We have three levels of capability, and the the biggest uncertainty, frankly, is not the technology. The uncertainty is the military's requirements. And the futures planning groups within the Marine Corps and the Army are all trying to figure out what exactly they need. While they're doing that, we're maturing the technology and demonstrating capabilities and characterizing their costs so that they have the information that they need to make a decision about what way they want to go. There's a lot of smaller, offerings in the 50 pound, arena, but once you get up into the
Yeah.
1,000 pounds, 1,400 pounds, 1,600 pounds, the viable options narrow significantly. So we're focusing more on the medium to heavy arena.
And again,
So, just one more thought. I was focusing on the military because it's such an urgent need there, but
yeah,
um, uh, the commercial side is also, I think, as big and maybe even bigger market. One of the key things there is the hurdle of getting FAA certification. Um, there are The FAA is trying to create ways for UAVs to be commercialized short of full type certification. A lot of that has to do with operating these vehicles in safe corridors,
yeah,
um, and there's a lot of economic sense to a cargo UAV that can, for instance, in oil rig support, a huge amount of manned helicopters are used to support those
yeah,
offshore
yeah,
rigs. But sometimes, the whole rig goes down because they don't have an O-ring. And
exactly. Yeah,
you hate to send out a 20,000 pound twin turbine helicopter in the middle of the night. In fact, I don't even think they allow themselves to operate at night. You know, and a autonomous cargo UAS can deliver that very cost effectively with minimum risk to crew life.
exactly. And you just look back at some of the incidents and stuff that's happened, and people are learning from it. So, that makes sense. When you said there about the safe corridors, what sort of altitudes are we talking about?
Well, I don't know exactly off the top of my head. I think the FAA has established 500-foot ceilings for these smaller UAV
Yeah,
operations. For the larger UAV applications, I think the philosophy that the FAA has is, are you as the operator are asking for authority to be able to operate, define what those parameters are, define where you're going to fly,
yeah,
explain to us the risk mitigation, demonstrate to us the platform has an acceptable level of reliability, um, and then we'll review it and give you our determination or make adjustments to your plan before we approve it.
yeah,
I think applications, particularly that offshore oil support, are no-brainers because you're out over the ocean. You're not
exactly. Yeah, yeah,
you,
yeah,
you know you're not threatening persons or property.
yeah, yeah. No, it's amazing. Like, I look back when I was a kid, and you see some of these comics and magazines, and you see all the different sizes of should we say just flight equipment going at different levels. It's going to be an exciting time in the next 20 to 50 years, huh?
Yeah, it's gonna be very exciting. Um, and there are a lot of practical integration challenges that have to be done. I think um, air traffic control is going to have to go through a transformation in order to be able to safely organize operations in this airspace. Um, it's doable though. I mean, with the technology there is doable, and we all take for granted getting in an elevator and pressing a button, but when you think back to the original elevators,
Yeah,
you had to get in the cage, a guy had to you had an attendant, they closed
yeah,
the
yeah, yeah,
cage, and a guy, moved the crank to the floor he wanted, and sometimes it got all the way there, sometimes it got halfway there. Um, so, if you think about the vertical lifts, the Wonka Vader. Remember that out of the movie where Willy Wonka flies through the roof, and you know if each of those is considered a node within the airspace, um, you can automate the deconfliction of those systems as a total system. And then when something goes wrong, you have to have established protocols to disengage from that system and and do what you have to do to save life and limb.
yeah, yeah. Nice. I mean, it's the mind. Well, I mean, if you just let your mind go with it, it's incredible what can be done, and then obviously you got to look at what the risks are, like you said, and it's such a wonderful subject matter, isn't it? It's
Yeah,
incredible,
yeah.
incredible.
Yeah, I'm somewhat, skeptical of the scale of these that are being talked about. A lot of the business models for the urban air mobility, um, talk about utilization rates and fleet sizes that make
Yeah,
your eyes water. But I think they'll find a happy medium. I just hope the economics close for them.
yeah, exactly. That's always the big driver. Now, just another one. So, as automation advances, how do you envision the role of pilots evolving in commercial aviation, especially in areas like urban air mobility?
Well, um, the the role of the pilot is going to move away from stick and rudder type flying because many of these novel configurations that are coming forward, they're really not practical to be flown by traditional mechanical,
Yeah,
electromechanical flight control systems, and so they're most likely to be digital, and that provides the opportunity for implementing a lot of autonomous functionality into the platform. And uh, let's face it, they say it's a sign of leadership to surround yourself with people that are smarter than you and in an aircraft flight control system informed by sensors and integrated in a larger network is going to have instantaneous information to be able to understand exactly what the location, the energy state, the deconfliction challenges, or whatever, of well beyond what the pilot can do. So the pilot's role really turns into a supervisory capacity where they're really managing the mission, right?
Yeah.
The computer can't divine the purpose, intent of the mission, and the pilot really is the one who is now relieved of the mundane or sometime not mundane requirements, stick and rudder, and really is managing the system to meet the ultimate client or customer needs for the platform.
Yeah, and just taking it to an extreme. I was talking to a guy, and we were talking about, how many people don't pay attention to the cabin address, and the pilots, and the good ones say, ladies and gentlemen, no matter how often you fly, please take a
Yeah.
moment, give a bit of time to our cabin. And he said to me, he said, imagine if you're sitting there on a plane and somebody says, right, ladies and gentlemen, this is Chris, I'm your captain. I'm not actually on board, but I'm sitting in our control center in such and such, and we'll be taking off in a few minutes, blah, blah. How you'd feel?
Yeah. I think, Chris, this is this is not a technology issue. We already do that. We already do that in the military. You have guys in Nevada or guys and gals in Nevada flying, aircraft over Iraq. Um, what in the vertical flight space, we flew back in 2010, the world's first, fully autonomous man-rated helicopter with a team out of Carnegie Mellon. The technology is there. Does it need to mature? Sure, it needs to mature. But the longer pole in that tent is a cultural, a societal acceptance.
Yeah,
And
yeah,
I think, maybe your and my generation is gobsmacked by the idea, but I tell you, the younger generation are incredibly comfortable with the idea of ceding a lot of their fate to um, intelligent systems.
yeah. It's absolutely amazing how it's changed. That's what I mean. Sadly, I won't be around in 50 years' time, but my God,
Yeah,
I would always love to go forward and back. And I
yeah,
think it's going to be an amazing, amazing place and platform for all the ingenious things that are going to come.
yeah,
Obviously, you're part of that, and your brother and your company, and fair play to you. It must be amazing to see how things have changed and that
yeah.
you're part of that change. So, thank you so, so much for joining us. It's such an interesting subject matter. And it always sparks questions whenever I see certain films now. I think, oh my God, what's coming or what the capabilities are there that are coming.
hmm Well, we're, more philosophically, we're transitioning from in the aviation world from systems based on how do we manage our ignorance, which is really, when we talk about design safety factors and what have you, all of that is established by experience within the industry between the industry and the regulators to establish enough margin for the unknown. And as we transition to intelligent systems, where the aircraft has an awareness of how it's being used, and where it's being used, and what dangers or threats there might be, the aircraft has you have the ability to manage how the use of the aircraft. I'm talking about loads and
Yeah.
vibration and what have you. And if you can do that, that means you can reduce a lot of the safety factors, which really comes down to weight, right?
Yeah.
You're adding weight to the aircraft because you don't know with certainty the loading of key components that that are going to be stressed, and so I think the big leap will be to for the industry and the regulators to develop confidence in knowledge-based certification as opposed to managing our ignorance. And
Yeah.
I think it's going to be an interesting evolution.
Yeah. No, it's amazing. Absolutely amazing. Well, listen, thank you so much for joining us on the podcast. As I said to you before, it's something I've always been interested with, and or interested in. And I think anybody out there that's ever been on a plane, if they let their minds go for a little while and the imagination roll, it's incredible what's coming. And wish you and your organisation the very best of luck with what you're doing, because everything you're doing is helping to improve what people take for granted in the first place.
Well, thank you very much, Chris. It's been a pleasure talking to you.
Absolutely. Thank you so much, sir.